Dan Linsley here, and Frank Carta as well. I've been with VMware 7 years. Frank's been about 5 years. And we'll be talking about achieving predictable response time with microservice-based applications on a service mesh. And so we've done a lot of research on this in terms of how to do this predictably, and I just wanted to share experiences with you with your team. So anyone run any like microservice style applications in Kubernetes currently, or just thinking about it? About how many services you guys run so far? I can't hear you, sorry. Just considering it, moving into it? Okay. No, all right.
Go ahead, Dan.
Go ahead, all right. So we're going to look at is all the problems we currently have identified with scaling microservices currently. We're going to take a look at the role of the application platform architect through a live demo. And through that, we're going to identify some current techniques that you could take away from this presentation on achieving predictable response times. And we're going to show a preview of a feature that the Office of the CTO has been developing for the NSX service mesh to help achieve predictable response times as well. So here's what we're trying to tackle today. We're looking at how can you ensure a consistent user experience in a dynamic and complex distributed application, but at the same time optimize for efficiency and availability. So ensuring a consistent user experience is easy if you over-provision, which is what most people do, but it's not efficient. So how can we get efficient with this? So a lot of teams have an application that they consider a monolith that requires many teams to coordinate together to actually do a build, test, and deploy. And their problem is that through microservice development and whatnot, that you would just be able to split everything out into microservices, implement auto-scaling, and all your problems will go away. And what we've discovered is that in fact isn't true. Literally, you're just scaling out your problems. You're not necessarily fixing any problems you may have had with your current application architectures. So here's how we go about scaling microservices currently. So we end up deploying instances of all the services together, say in a VM, and front it with a load balancer. And over time, you end up identifying bottlenecks. So you'll instantiate extra full instances of the application, and then you'll have many, many instances, right? So just to solve certain small bottlenecks, we'll deploy full instances of the full application. So this ends up deploying way too much instances to handle, and it's a lot of waste. So ideally what you'd like to do is once you've identified an instance that has a bottleneck, you would just scale out that particular instance instead of scaling every service that you would need. So over time though, it kind of breaks down what we've discovered. The path that you take to complete a transaction over time is different. And most of the time, each of these earlier services work. Sometimes there are certain services in the graph are slower, and some of them fail to work at all. And in fact, just earlier this week, Frank and I were testing out a demo and witnessed this scenario for a particular service in our demo, where one of the services just would crash and still provide some responses, but they were incorrect. So Frank can go into some more details on how we'd be able to achieve that as an application platform architect.
Thank you, Dan. All right, so as Dan mentioned, there's a lot of issues with just microservices and scaling them out, right? So we've kind of identified that. In the Octo group, we were dealing with this challenge of how can we take these microservices, scale them, but then also achieve predictable response times. And that's truly what you want to get to, right? That end user experience of this application or this page is working correctly. And so as we started talking about solutions and possible ways to correct this, we realized that we kept coming back to the role of like an SRE or an application platform architect. Really quick, how many of you know what an SRE is or have heard of SRE? Okay. In the Octo group, we like to call this an application platform architect. It has slight modification, but pretty similar. And so we started looking at this, and it's like, okay, well, how do we automate their life? How do we get it so that we don't have to spend a person, they have to sit there all these hours, watch this application run, fix it, and constantly monitor it. And so we thought, okay, well, if we're going to begin down that path of trying to automate it or write some fancy algorithm, we need to understand what that life is day to day. And so we said, let's take an application and let's deploy it and let's run it like we would in production. Okay. Now, how many of you have heard of service mesh or service mesh? Familiar? Istio? Okay, cool. So you guys are somewhere. So with the Istio distribution, they have a lot of example applications. We took the book info application because it's a polyglot, yet it's pretty simple. So it has a lot of different runtimes, and that's what we were looking for. So this is what the book info application looks like. You can see over on the right, there's Python, Ruby, Java, Node.js there. And basically it works like this. There's 4 different services. The product page is responsible for receiving all your requests, making external calls, dependency calls, building up the response, and returning that back to the client. That's written in Python. Now over on the left is the book details section. This is written in Ruby, and that just returns some details on the book. Then on the right, we have the review service. Now in the Kubernetes world, a service, really think of that as like a load balancer. So you note here, there's actually 3 different versions of the review service, right? So you'll notice as I reload the book info application, you'll see this section kind of change a little bit. That's because we're just round robining through those different versions, okay? And also keep in mind, when we start talking about deployments, we'll be deploying 6 different versions as opposed to 4. So sometimes that's confusing, but a service basically is just a load balance for an implementation, okay? And then finally, we have the rating service, which returns ratings for reviews. That's that Node.js part of the application. So not super complicated app, but just enough to give us an idea on how to scale these different services with different application runtimes, different characteristics. Did you have a question? Oh, okay. Sorry. All right. So we're going to take a look at this book info app under load. And you guys probably noticed right when I got up here, my machine decided to do an Xcode update. So I don't know what that was about, but let's take a look at this application. It should be running still here. So here's our book info app, and I'm going to reload it a few times. And you'll note it might be hard to see, but the response times are about 650 milliseconds. Now in the US, this is about 300-400. Because I'm running this in East Oregon, I get faster times, and obviously it's a little slower here, but good enough. So that gives us a baseline. We know how there's not much load going. Right now we have light load hitting this page. So this is how the application behaves by default. Now, when we apply heavier loads, this is going to change, right? And so that's what we're looking at. Now what I'm going to do here is I'm going to get a baseline. I want to display some baseline metrics for you so we get an idea of what this application looks like just kind of normally, and then we'll take a look at what it looks like when we hit it with heavy load. So you can see with not much going on, there's some numbers. Just kind of take mental notes of what these look like. And what we're going to do next now is I'm going to apply a heavy load to this application, and we're going to see these change, and what we're going to notice happens, the application just goes down. So if I'm an application platform architect, I can't just take someone's beautiful code and just deploy it. I need to put some thought into how it's going to run when there's load, right, or there's some constraints. Also, before we move on, we're also I mentioned that we're using Istio and Wavefront. The nice part about this is when I use Istio, I get service metrics I'm not just looking at my Kubernetes pods, if they're running, or I'm not just looking at the health of my environment. I'm actually getting service level metrics on my different services, right? And I can observe how those are behaving inside the container. So let's go ahead and apply some heavy load here, and we'll watch the application begin to fail. Oh, shoot. That's the wrong one, Dan. 1 second. Sorry, that's the wrong one. So we're going to do a full redeployment here. Yeah, there's no HPA, that's fine. So let's just go ahead and redeploy our app. We got an hour. So what I'm applying here is basically a baseline deployment of the application. There's no sizing, there's no HPA scaling, it's just basically here's the container, spin this up.
Yeah, it's the sample out of the box, right?
Yeah, sample out of the box vision here. And let's go ahead and make sure this is still running. Okay, that's good. And if we give this a second, we'll start seeing our metrics come up. Now, we had light load hitting our container before. What we're going to want to do is now I'm going to take a heavy load, and we're going to hammer that application, right? So let's remove our light load first. I got to go. So that's going to remove the light load that we had running, and then we're going to apply our heavy load. Okay, that's it one. Okay. So now we're going to make the book info application fail. Now the light load previously was kind of simulating some light activity, maybe 4 or 5 users hitting it. This heavy load is actually going to simulate maybe 500 concurrent users, so a bunch of threads hammering the URL to get the page to crash, to overload it, okay? And we can see what that looks like here. If we refresh, we can already tell, just after one refresh, it's taking about 2.5 seconds now to return, right? So we're starting to see some degradation in the service. If I refresh this enough times, yeah, you see actually we just took the whole application down, okay? Now we can also see some bottlenecking if we look at, if we just kind of run a quick top here. And you can notice this number looks pretty large right here, right? This is the CPU for the product page, and we can already tell that this number's kind of shot up. So we're already starting to see some behaviors in the application that beforehand we really didn't know what was going to happen. We can already tell that this is a bottleneck that we'll have to deal with, right? So as an application platform architect, these are the steps you should probably take before you deploy out to production. And if we want to use our service mesh for some observability, we can kind of come over to the graph, and maybe you can see this, but you can see we got tons of 503s getting returned here, right? So it's almost like a DDoS attack. We're just getting hammered right now, and that basically that ingress controller is saying I can't handle all these requests. So we're not scaled properly, okay? So there's our book info application scaling. Now, as I mentioned, if I was a inexperienced and naive application platform architect, I would have just deployed this application, and I would have been in a lot of trouble getting that call, hey, the application's not running, what happened? So you can't really stick with the old paradigm where the developer kind of throws you an application and then the infrastructure admin just gives you some infrastructure and they take off. As the application platform architect, I really need to bring the teams together and start communicating across all the teams. And we need to get to the point where we're agreeing on certain level of commitment and what we like to call an SLO, right? And this is a common language between the teams because now we can commit to certain things for the end customer who's going to view this. So as a developer, I can hold them accountable for latency, right? it's doing, their code's doing a bunch of processing and it's taking too long. Well, that's not going to get me to my end user good experience for my customer because there's too much latency in the click or whatever page is coming to load. Same goes for infrastructure, right? I need to involve them too to understand any kind of constraints or whatever limitations there are on the infrastructure side to make sure that we're networked properly and all these things. So we like to talk in terms of an SLO. So one of the starting points when you get an application is to get everyone to agree to a certain level of quality, okay? And we define this as an SLO. So for the book info application, what we said is our application has to be efficient, which means it has to auto-scale. We have to use the most of our cluster. The other thing we said is it has to work well. And so we committed to saying that 95% of the requests need to come within a second, okay? And 98% of those need to be successful. So imagine I could meet my latency by returning a bunch of 500 errors, but that doesn't mean that those are successful, right? So these two kind of play into each other. And then finally, we kind of made up some number and we said, let's just shoot for 500 concurrent users. That's a good, moderate, usable use case for our application. So we defined our SLO. Now the next step we took is we said, okay, we have this SLO. What are the things we're going to need to test and deploy properly, right? And we came up with all these things. We're going to need a platform. We need to deploy somewhere. We're going to need some automation, right? We're going to need scripts. We want to make sure that we're consistent. We can repeat the process over and over. We're being very methodical and almost scientific about how we're testing this application. We need telemetry. This is where Istio Service Mesh comes into play. We need to be able to observe how our application is performing, not just Kubernetes dashboards, right? How my infrastructure is. How's my application running? Is my service 200s or are they 500s? And then some profiling, centralized logging is always important, and some sample data, right? Need to be able to load it. So this is our load generator that we're showing here. And then we get to this point what we like to call the onion of dependencies. So we defined our infrastructure, which is Cloud PKS. That gives us a Kubernetes cluster. We settled on using Helm to do some installations and some of the management of the control plane for us, which we use to install Istio, which is our service mesh, and also Wavefront. So that dashboard that we were showing you before, if you haven't seen it, that's how we're observing the metrics that we're gathering from Istio for our application. And then ultimately, that little terminal window that you're seeing, that's a container that we wrote with a bunch of scripts to make sure that, if Dan's working on it or I'm working on it, we're working off the same container and the same exact scripts, right? There's no variations on how we're deploying. And we're also following good development practice. We can source control those, push those up to image repositories. Now, initial sizing and auto-scaling. So there's a lot of different ways to do this, right? How do you take an application, know how to size it, know how to auto-scale it initially? In our group, we decided to take a very simple approach, and we just said, okay, let's take our deployments, let's just set them all to the same size initially, and set them to the same auto-scaling, and when we hit them with load, we're going to watch the behaviors change, right? Because I don't know if the product page is going to be a problem or if the reviews service is going to be a problem. I don't really know yet, right? So we kind of leveled the playing field, set them all to the same, and then we hit it with load. So how do you do that? And we're going to talk about that. But before I do that, I'm going to apply the optimized deployment YAML really quick. And it takes a little while for it to kind of self-heal, but we'll see that book info application that we deployed will actually heal while that heavy load is still running, okay? So let's go ahead and apply that now so we have some time for that to run.
Any questions currently?
Yes,
as well?
thank you, Dan. Where's my
Looks like
timer?
no questions yet.
No questions, all right. All right, and we'll talk about how we get to this optimized version of the YAML here. And do note, right, you can see that these services that we deployed before actually stay configured, right? So this is including some sizing and some limits for our containers. And then also you can see some created things here. These are the HPA or horizontal pod autoscalers, which give us our scalability. And we'll talk about that as well. Sorry? Yes. Yep. Cloud PKS. Okay. So I mentioned before we're taking a simple approach, right? and we're going to set everything to the same baseline, same size, same scaling metrics, and we're going to watch the behaviors, and then we'll adjust. But the place to start is, well, how big is my cluster? How big are my worker nodes? Now, the advantage of using containers is that I can compact a bunch of containers per worker node and really stuff them in there, right? So I really want to optimize all of my worker nodes. So you need to look at the size of your worker nodes and consider what they look like. Now in Cloud PKS, they're relatively small. So I get 2 CPUs and 8 gigabytes of memory. That might not sound like a lot, and typically you don't think about that on the cluster level when you deploy your workloads, but it matters, and we're going to see why. Now in the Kubernetes world, one vCPU or one CPU is what they call 1,000 millicores, and that's how you kind of get the division of containers and allocate so much CPU to containers. So they kind of divide it up into 1,000 millicores per one CPU, okay? So with our Cloud PKS containers, or worker nodes, we get 2,000 millicores. Now Kubernetes, because it's doing some management of the worker nodes and all that, it reserves some space for itself. So you're really only allocated, 1,500, we're already down to 1,500 millicores out of that 2,000 that we had initially. Now there's also a bit of a gotcha. If there's any daemon sets, now a daemon set in Kubernetes is a type of deployment that's applied to all nodes in the cluster. Examples of this would be any kind of networking solution, logging, or even storage that you're using to extend your platform or provide your containers. Those typically get deployed as a daemon set. And so those eat into your space off your worker node as well. In Cloud PKS, the networking daemon set uses 250 millicores. Okay. So that leaves us, from that 2,000, we're already down to 1,250 millicores for our application, or our pod allocatable. Now a pod in the Kubernetes world is kind of your unit of deployment, right? Everything gets deployed into a pod. So when we're setting our sizing, you'll be setting those towards the pod size. So we got 1,250 millicores to work with. If you do some kind of simple math, right, I can see that's divisible by 5. So now I'm kind of saying, I know I can get 5 deployments per worker node, okay? Just some simple math, right? Nothing crazy, I'm just kind of making guesswork. These are initial sizings. Now, we mentioned that we're using Istio. Now, Istio uses a concept of a sidecar. And the way a sidecar works is it actually inserts a proxy or another service inside of your pod, right? So this is going to run with your application. Now, the nice part about this is I can modify my application's behavior without changing any code. Istio gives me the ability to do routing, do layer 7 type routing. I can inject faults. I can inject latencies. I can do blue-green deployments without ever touching any code. So this is a very powerful tool, and if we have a little time left, I'll show you some examples. Where's our time? Okay, so we reserved some space for our sidecar. Now that leaves us with 150 millicores for application, right? So now we got some initial sizing for all our deployments. We're only talking about CPU here, but you could do the same thing with memory. This is more just to show you what dependencies you need to look out for, what's running there.
Yeah, we were constrained by CPU in this particular kind of
CPU
scenario.
was our main concern in this case because we only had 2.
Same thing for memory, yep.
All right, so we got initial sizing. What about scaling, right? In Cloud PKS, in our cluster, we had 16 nodes. So I know that if I have 5 per node, and I got 16 nodes, that gives me a total capacity, in theory, of 80 pods. Okay, so now I know I can take my service and scale it out to close to 80. Not totally 80, because we have to remember there are other pods running in our cluster, right? Kubernetes has some things. Istio's got some pods running in there, so we can't use that full 80, but we can get close. Now I've mentioned this before. Remember, the services are considered like load balancers, so we're not scaling 4 services. We're actually scaling 6 deployments, right? That review service has 3 different instances, so we need to consider scaling 6 different deployments for version 1, 2, and 3 of reviews. So doing some simple math, right? 6 times 12 gives us to 72. It's pretty close to 80, right? So now I know I can scale all my deployments from 1 to 12, number of replicas here, and get close to that 80 number, right? So I'm really maximizing my cluster. And then kind of a general rule of thumb, 80% threshold CPU memory. That's going to be our triggering of when to scale, right? So if any one of our pods kind of starts hitting that 80% utilization of CPU memory, start scaling it out. Okay. Again, these are just baseline. These change as you run the application and you see how it behaves, right? But this is where we're starting.
Any questions?
Yes, any questions?
All right.
Okay. So you could see, just really quick, we're looking at our metrics, where we had kind of this high number of errors before, that's dropped dramatically, and our throughput has actually gone up, and we're getting pretty good numbers back with our optimized version of the book info application. If I come back over here, we should see that our application's back up, and it should be responding. That one took 3 seconds. And you can see it's kind of back to those initial 600 to 800 milliseconds we were seeing initially. So we still have that heavy load hammering our site, but now we've recovered, okay? I'm sorry, one more time?
Yes, sorry.
Yes, sir.
Which module is taking care of the scale? They used to operate with architecting flow.
The HPA. So when I mentioned that there was an HPA, the horizontal pod autoscaler, that's part of a Kubernetes construct.
Okay. Kubernetes is not relocating workers like having hyperscale.
It's within Kubernetes. Cloud PKS is giving me my Kubernetes cluster. Kubernetes is monitoring and deciding to scale out. Yep. Okay. So you can see we got a lot more services, right? And this is an output from our HPAs. We can see that our numbers are pretty good. This first side, I think, is CPU, and the other one this might be memory and then CPU. And you can see we're pretty close to our thresholds. We're still hitting that product page pretty hard, but it's performing still, right? And you can see our number of replicas. And this is what I always find interesting, is you never know how an application is going to behave until you hit it with load. This product page scaled out like crazy, whereas maybe some of our reviews only needed a couple instances, and our details needed a little bit more, okay? So this is always interesting. Every application behaves differently with different traffic too, right? So I would recommend probably optimizing for your burst case, your high-level cases, but that's that. Okay, Xcode. All right, so you think we're sized and auto-scale, mission accomplished, right? We're good. But not so fast. There's a couple more things that went into that YAML that we should talk about. How am I doing on time? How am I doing?
30, you're good.
Oh,
Yeah.
okay. All right, so health checks. What we noticed when we ran this application for a while is that the reviews service would just crash. It would just run, you'd hit with load, and it would just stop running at some point. And so if you were to look at your Kubernetes dashboards, you would see that this pod was running and everything was healthy. Depending on which review I hit, when I hit the book info page, I probably wouldn't even see an error at all. This was just one version of the reviews. It's like version 2 or something, would just crash. So you might get calls saying, hey, the app's down, and I would look at it and be like, it looks fine. Look at my dashboards, it looks fine, there's nothing wrong. Now with Service Mesh, because I have that sidecar, that proxy, I'm able to gather telemetry from my service, right? So I can see that there's one in particular returning 503s. I wouldn't see this from some of the other standard dashboards. So this is a nice thing about a Service Mesh is I get the observability of how my services are performing. Okay. So we kind of took the approach like maybe let's think like maybe as an SRE, how can I fix this? Maybe I don't have time to go back to the developer. What can I do immediately to make this a little more resilient? Kubernetes has a concept of probes, and they do a lot of different things. One in particular is a liveness probe, and this is like a health check, right? So not only can I ping an endpoint, but I can make sure that I can also implement it so I make sure it returns to 200, or make sure it returns a certain script, right? Because that review service was still running in my pod, but it wasn't returning 200s anymore, it was returning 500s, right? And so you can use a liveness probe to pull that out and to visualize that. And what this will do, based on your time period, your failure threshold, you can actually say restart the pod when that happens, okay? And so that worked great. That fixed our review service. But the funny thing is when it would restart, and then it would restart, and then it would restart. And this is kind of where your application knowledge needs to come into place. Because the reviews was running in a Java web container, that web container needs a certain amount of startup time before it's ready to receive traffic. Otherwise, it just kind of fails again, or it doesn't respond. And so there's another concept called a readiness probe, which is similar to a liveness probe, but it basically says, when you start this pod up, you're going to check this endpoint, but give it some time before you start sending traffic to it, okay? This would be, you can think of this obviously for a web container, but maybe for a database that needs to, or a cache that needs to warm up and do some initialization. You can configure that with the readiness probe. Okay. Now, with our probes in place, we had some pretty good health checks on the review service, and you could tell this is our problem child, right? But you could still see it blips, right? And if you watch these metrics, you'd see these blips, and it would recover. It would recover. However, that's not good enough. Now, instead of blaming this just on crummy code and blaming the developer, like, hey, your code sucks, go fix this, we kind of took the approach like, maybe again, this was a third-party library we have to use. I don't have a solution. How can I fix this without changing any code? And in this particular case, when we dug into it, we actually realized it wasn't a code problem, but it was actually just running out of memory. Now that would kind of make you think, well, okay, great, we'll go to this is that deployment YAML that we're deploying. Okay. If I go to my resources and my request, why don't we just bump that memory up, right? That'll solve the problem. Well, this is where understanding your application runtime comes into play. Java 8 and below is not container aware. So unless you send a flag, give it a particular flag to tell it's in a container, or give it guidelines around what its memory are, by default, Java's going to look to the host it's running on and assume it can take half of that memory. So our cloud PKS nodes, because they have 8 gigabytes of memory, this container was thinking it had 4 gigs to use. So it's running out of memory, right? Even though I set it to 2 here. So there's like I said, there's ways to do this. You could set a flag on the runtime, tell it's running in a container, or you can give it some Java args and give it some guidelines on what its memory allocations should look like. Scaling up versus scaling out. So the product page, what we saw earlier, kept hitting CPU pretty high, right? So kind of your natural tendency is to think, let's up the CPU on that, give it, it's doing some Bitcoin mining algorithm, I don't know. Let's give it some more CPU power. Well, unfortunately, when we did that, it made things worse. It actually dropped the performance. So we tried to scale it up, but it didn't like that, right? Counterintuitively, shrank the CPU, allowed it to scale out, and it made it much more happy. Now, this is typical when you see high CPU utilization. A lot of times it's memory constraint. In this case, it was a socket incoming request constraint, right? That product page is taking all this requests, and it couldn't keep up. It didn't need CPU, it just needed more system resources, right? The networking stack. Book info meets SLO. We could check in with our app one time. Let's see how it's doing. Any questions? No? Okay. Do we have time to do some other examples? How much time do we have?
Yeah, we got time.
Okay.
You got time.
You guys want to see a couple other things you can do with NSX Service Mesh? Okay. This is kind of cool. So I'm going to go ahead and kill our load generator just so we can see some examples.
Am I off?
And so I mentioned before I can modify the behavior of my application with Service Mesh, right? So what I'm going to do now is I'm going to actually introduce a fault. So as an application platform architect, I can take an application and see how resilient it is. What if I just kill a service? Does it take the whole page down? Or is the application smart enough to know that this section's down? And does it give me a nice message? Okay? And so these are the type of things that you should be doing as an application platform architect. So we're going to do this error injection here. Oops, dang, I keep doing it. It's going to fail. I got to go up a directory. Okay. Okay. Come back to our application. So as I refresh it a few times, you'll notice that it's kind of toggling us between two different versions of the review. And you'll see this go from red to that one where there's no ratings there, right? Now, if I sign in as these user JSON here, I can pin myself to a certain, I've actually injected an error now, but I'm routing based off the header that I'm passing in, right? This is that nice part about that L4 through L7 routing I can do with the service mesh. Didn't change anything in my code. I just added a rule that said, if I'm this user, make this service give me back a 500 error for that service. So now I can inject different faults around the page and see if I can crash the application. Right. Pretty neat, right? And if I sign out here
Were there
again.
any code changes on that, by the way?
No code changes, right?
Oh, okay.
Again, just configuration changes. And I log out and the application's back to normal. Okay. The orders on this stuff. All right, so let's go ahead and remove that rule. And I've removed that rule, and if we go back to our application, even if I sign in as JSON, that rule is not applying anymore. Okay? So pretty cool. Now you can do similar things. I can also inject latency, right? So I can say the same thing for user JSON, make the detail section take 10 seconds. See if maybe some weird things start happening on the front end. You can also use this for blue-green deployments. I'm not going to show all this, but you could do, maybe I have 2 different versions deployed. I want everyone to see version 1 and then do a soft launch of version 2 for a certain set of users. You can do that same kind of routing. And again, no code changes. It's pretty cool. So these are the tools that you're going to use as an application platform architect. Today, we mostly used it for the observability, right, to get the metrics and see how my service was behaving. But in this case, you could do these other things to see how resilient the app is as well. So let's kind of do a quick wrap up, and then I'm going to hand it off to Dan, who's going to talk about some more innovative things we're doing. Kind of what have we learned, right? For the most part, we can implement solutions for our microservices to meet an SLO. And here's kind of the formula to follow. First, you define your SLO. You talk with your team, all agree on certain metrics, get accountability, a quality of service that you're going to commit to. Second, look at your initial sizing, right? Understand your sizing, understand your scaling. How am I going to size it? How am I going to scale it? Look at your cluster, look at your nodes. Fourth, insert certain health checkpoints. Look at endpoints you can use in the service. Make sure it tells you the status of the application, not just whether it's up or down. And then fifth, application runtime tuning. Look at the runtime, right? Is it a script? Is it Java? Is it Ruby? Understand how that's working inside the container and what it needs. And then six, test with load and vary the load. Start with a light load, start with a moderate load. Hit it with a high load. See how the application performs and behaves, because you notice that product page performed pretty poorly initially, and we saw it scale out differently, right? The details scaled out a little different than reviews. So that's all good and well, but there are some gaps, right? This isn't the solution for everything. Our process, even though it kind of looked kind of quick and we did it over an hour session here, it's very difficult and time consuming. This took a course of days, maybe even a couple weeks to really get to that final deployment YAML. Okay. The other thing is it doesn't consider the full call graph as a whole. That might not make sense just yet, and Dan will show you why that matters, but we were scaling our services independently, right? We scaled the product page independently from the reviews, independent of the details. We didn't consider if we were overwhelming services downstream, okay? So we're kind of limited with the HPA. We're limited to Kubernetes cluster, so we were only scaling within our cluster. What if we had a service outside of our cluster, like an AWS database or anything like that? We're not taking any actions there. And then we're limited on our triggering metrics, right? There's no conditionals. We basically said, if it's CPU 80% scale, if the memory's 80% scale. What if you wanted memory and CPU? You can't do that with the HPA, right? It's one or the others. They're independent. And then ultimately, finally, it's passive or reactive. We're not really considering any kind of traffic patterns or even doing any predictions about what our load's going to look like beforehand. We're waiting until there's almost a problem before we scale. Okay. And with that, I'm going to get over to Dan that's going to talk about some more things we're doing.
Sure.
Yep.
So like Frank mentioned with the HBA, it's fairly rudimentary in that it only looks at single metrics. It can't really customize it. It's built into the controller manager. It's very reactive. An alternative that we want to develop is what we call the predictable response time controller that takes a look at the whole call graph. Right, it works across non-Kubernetes types. We can have, say, names, configurations per whole namespaces instead of, say, per deployment, and look at a bunch of different metrics. Looking at not just infrastructure metrics, but application metrics as well. And we want to be able to eventually, be predictive and take a look at history and forecasting over say, a week of traffic, identify appropriate times of scale, whatnot like that. So in a nutshell, the controller we're developing is a dependency and topology-aware autoscaler that maintains one or more SLOs across any cloud boundary. So with this, we end up defining an SLO in code. So the SLO that Frank talked about, you develop between your teams. So each team in their application or their data service would define an SLO, and we'd actually codify it. It wouldn't just be a Word document or a SharePoint or a wiki page. It'll be codified into a controller. So in this case, this is how the topology of that book info app looks without PRTC, with just using, say, the HPA. You end up defining metrics per service to define their health and scaling characteristics. And then with PRTC, though, we can define an SLO for an entry point in this case. So in this case, product page up there is the entry point that consumers consume. And in this case, we defined a successful response time of under 600 milliseconds we want to ensure, and our error rate under 10. And then that product page has dependencies of several other services that eventually depend on a MongoDB that we've implemented as well as a separate SLO. So in this case, what you see here is a composite SLO of a microservices app depending on a backing database that could be in a different cloud. Okay. Any questions so far? All right. Okay. So here's a quick demo of the controller in action. So what we're going to show here is a time lapse, because it's hard to demo this in real time. We end up showing traffic patterns over, say, about 2 hours. And so on the left here, you'll see the response time of the requests and response time of the application growing, and the number of pods on the right. And the top purple line here is a threshold that the response time should stay under. And so once the response time threshold was violated, we took a scaling action to reduce the response time. So this looks very similar to, say, how like the HBA may work, and it may look like it didn't scale soon enough, but when in fact it's quite different, and I'll show you exactly how the events occurred. So we took a look at the logs that you saw scroll by. We analyzed the logs, and I'll show you exactly how this algorithm differs and why we think it's superior. Okay? So we exceeded certain thresholds that caused a scaling action, but how did it scale each service? So the PRTC algorithm works in that it looks at the bottommost bottleneck service first to ensure that it's healthy before scaling anything higher. So in this case, when we needed to scale, it identified the bottommost bottleneck service as both the rating service and the details service. So it scaled those concurrently.
That's a big difference right there, right?
Yeah, concurrently scaled them. So it's iterative. So the next data collection cycle, I identified the next bottleneck was reviews. So it scaled it. Next cycle identified ratings as a bottleneck. Then reviews before finally the product page. So the key here is that we always scale from the bottommost bottleneck up. Otherwise, if you're front end, typically front end services scale out much quicker than say back end services or databases. So typically the HBA would scale out, say, their front end first in this scenario, and then overwhelm your back end services, causing the whole application to collapse. So, any questions on that so far? Does that make sense?
Key thing to think about is perhaps that database is shared between another application.
Yeah.
Right, so if we overwhelm that downstream service, we're taking down other applications. So our blast radius is very large, as opposed to making sure the bottom service is healthy before we move up.
So this is a very simple scenario where we only have four services. But imagine if you had, say, 50 to 60 different services, calculating this becomes much more difficult. You need more automation like this to do that, that respects the call graph in that regard. Any questions on that? So this is going to be, it's actually a tech preview feature of NSX Service Mesh. Part of the DevOps features of that product. Still in progress here. Yep.
Yep. If you have any questions, you can shoot an email to there. Yep.
Any questions on that controller, the feature, or as well anything in that space around scaling apps with Istio and whatnot, you can reach our teams at these email addresses.
Reviews.
That's it.
Thank you, guys.
Oh, yeah. So we have a couple other sessions by our team. So, yeah, this may have been the final session of the show, but you could go check the recordings, check out these other sessions that are related.
And then finally, make sure you fill out your surveys.
Fill out your survey.
It helps us. We appreciate it.
Helps us a lot.
Especially if you have good content. You know, if there's questions or stuff doesn't make sense.
Yeah, questions
that
on the
feedback
content
is always
would be great.
helpful. Thank you, guys. Appreciate it.
Thank you.